Hey everybody, let's greet each other properly. Good morning. This is Mr. Ainsworth, and we're going to get into the second half of this video on linear growth of arithmetic sums, okay, which are series. You take an arithmetic sequence and you add up all the terms, okay, and what do you get? Well, I first started talking about Gauss, and I told you about the Gauss story and how he solved a what is a complex problem for a fourth or fifth grader. He did this when he was very young, and I talked about how he got creative and how he might have added, the first 100 counting numbers so quickly. And we took that technique and we applied it to all kinds of problems. We talked about the tractor problem, and then we went and I solved a bunch of summation problems of arithmetic series for you guys. And so now what we want to do is turn to page 12 in your notes in chapter 10 in modern math or discrete math. And we want to take a look at some different type of problems using the same technique or same summation formula, but how to deal with situations where certain things are missing. All right, so let's take a look at the first one. What happens if the last term is missing? You want to sum the first 1,000 terms of the arithmetic sequence. So let's take a look at this and uh, and figure out what we need to know. So the very first thing we need to do is write down the formula, right? Okay, so let's review. So the sum of the first n terms is equal to the first term, first plus the last, all right, times the number of terms, n, okay, the number of terms, which we'll call n in general, divided by 2, because remember how we double count it, so you always got to divide that by 2. So there's your summation formula. Remember, capital S, all right, stands for sum or summation, sum of the first n terms, where n stands for the number of terms. Okay, so there's the formula that I spoke of in the first part of the video here. Let's take a look at what we have, okay? So if you look at analyze the sequence here, we know the seed. We know p sub 0 is 5. All right, so that's great. So we got 5 here. And we know that the common difference is 7 because 5 plus 7 is 12. So it's plus 7. All right, 12 plus 7 is 19, etc. So there's your common difference. So we know the seed and we know the common, what we call the common difference, what you add to get to the next term. Okay, so we know the first term, that's p sub 0. We don't know the last term. But we know that we have 1,000 terms to add. So the question is, what term are we looking for? Okay, so let's outline this a little bit here. So we got, I'm just going to write this out again. So 5, 12, 19, plus 7 is 26, etc. Okay, so this is p sub 0, this is p sub 1, this is p sub 2, p sub 3, and we want 1,000 terms, okay? Well, the question is the nth term or the last term, this is the first, right? First term is 5 or p sub 0. The last term, what is it? Is it p sub 999 or is it p sub 1000? Okay, so I'm going to make a mistake. I'm going to make the most common mistake. I'm going to assume that it's p sub 1000, okay, which is a mistake. Why is that? Well, if you take a look at this and if you count up the number of terms from 1 to 1,000 is 1,000 terms plus the seed. Okay, and if you add the seed, you get 1,001 terms. So this is not the last term. All right, remember we start counting from 0 and not 1. So the last term out of 1,000 terms, all right, is actually p sub 99. Okay, 999, excuse me. Why? Because we start counting from 0. Okay, if you count from 0 to 999, there's 1,000 terms. So we need to find that first. Okay, and I talk about this right here because it's so important. Most people make a mistake that it is p sub 1000, okay, because it says 1,000 terms, but because they forget they start counting at 0. Okay, we don't start counting at 1 in these problems. We call the seed p sub 0 when you start counting at 0. So 0 to 999 is 1,000 terms. 1,000 terms, believe it or not. Okay, so what we need to do is find that first. So p sub 999. We got to figure that out. But to do that requires the arithmetic sequence formula. So let's get that first. Okay, so what's p sub n? Well, p sub n is equal to the seed plus d times n. That's from the first section, okay, 10-1. So let's write that out first. So p sub n, what is that? The seed, which is 5, plus the common difference times n. Okay, there's your explicit function. This is a good review, by the way, okay? This is your explicit function. Now we substitute 999 in. So p sub 999 is equal to 5 plus 7 times that, 999. So what is that? Okay, we'll start working on it. Okay, we have to take 999 times 7 and add 5 more. So what the question is, what do you get? All right, so let's go ahead and do that. Let's work it out. Okay, come on, calculator. It's going a little slow right at the moment. So let's figure this out. So 7 times 999, all right, plus 5 more. That's 6,998. So 6,998 is p sub 999. It's the 1,000th term. Okay, now that's not what we're looking for. We're looking for the sum. Ooh, we're looking for the sum. So the question is, what is that? So we gotta, I'll tell you what, we're gonna continue right down here. Okay, so the sum of the first 1,000 terms is equal to first plus last. So 5 plus the last one, 6,998, times how many terms there are, which is 1,000, right? All right, divided by 2. So the question is, what is that? So let's figure that out. So let's take 5 plus 6,998. I'm not using parentheses, so I have to hit equals here. Okay. If you use parentheses, you don't have to hit equals. You got to times it by 1,000. Ooh, got a little crazy there. Not 10,000, but 1,000 divided by 2. All right, and then check your work. All right, so that's 3,501,500. So 3,501,500. Okay, a tough problem if you didn't know the formula. And I'm talking about this one right here. Okay, you have to know your summation formula in order to solve these problems. And then using a calculator, that kind of helps too, because these numbers get huge. Okay. So the question is, how do you handle all the different situations? Because, my friends, there are a lot of different type of situations, and that's why my notes have so many examples in them. All right, because if I just said, okay, here's one example, go figure out the rest, boy, you would have a lot of fun. Okay, and you wouldn't like this class so much because it would be super difficult. But, I'm better than that. I give you a lot of examples. So here we go. Let's do some more. So in this one here, it says find the sum, find the given sum, okay, of the arithmetic sequence. It's arithmetic again, so that's good. Given the number of terms in the start, okay, the start, that's p sub 0, and the number of terms, that's n, find the sum. Okay. So we know that there's 200 terms. So we got to find s sub 200. Okay, we know the seed here is 5. Okay, so that's the first term. The seed equals the first term. That's 5. The question is, what's the last term? Okay, last. We know the first term is 5, but it's the last term. So we need to know that because finding s sub 200 requires that. It's always first plus last times the number of terms divided by 2. So we got to figure that out. Now, remember, we start counting at 0. So the last term's not p sub 200. Okay, that would mean that we have 200 plus the seed, or 201 terms. So the last term is actually p sub 199. And that's the last term. That's the one you need to find. So you got to find that first. Okay, so to do that requires the explicit formula again. So p sub n is equal to the seed plus d. Okay, and let me see, 5 plus 11 is 16. So there's the common difference, plus 11 each time. You can check it. Plus 11. There's your common difference. So it's 11 times n. There's your explicit formula. Okay, now you plug in 199. So p sub 199 equals 5 plus 11 times that number. So what is that? Okay, well, you ask the TID4, okay? As long as you put the numbers in correctly, it's going to help you out. So 5 plus 11 times 199. Okay, you get 2,194. So 2,194, that's the last term. That's this one right here. So here we go, first plus last. So 5 plus 2,194 times the number of terms. Okay, whoops, didn't mean to do that. Plus times 200 divided by 2. Okay, remember, this means the number of terms. That's this. And that's this too, by the way. Okay, and so what do you get? All right, let's do it. So we got to add 5 to it, times 200, divided by 2. And as long as you press the buttons right, you should get a good answer. So 219,900. So 219,900 is the sum of the first 200 terms of this arithmetic sequence. All right? So you just got to ask yourself, what do you know? What are you trying to find? All right? If you don't know something and you need to find it, well, then find it first and then go with the flow. All right? So let's try a few more, okay? We know the seed on this one is 2. That's your first term. We don't know the last term. But if n equals 100 here, if there's 100 terms, and you start counting at 0, what's the last? Oh, the person next to you. Okay. Mrs. Ainsworth, what do you think it is? Okay, well, you probably didn't hear this, but she said it correctly. It's piece of 99. Okay, way to go, Mrs. Ainsworth. Okay, she's having dinner with me right now, guys. Okay, so getting a little goofy here. So let's find piece of 99 first. So piece of n, the explicit formula, is equal to the seed plus d times n. So this is equal to 2. Let me see, the common difference right here, 2 plus 5 is 7, plus 5 is 12. So there's your common difference, so plus 5n. All right, let's plug 99 in. So piece of 99 is equal to 2 plus 5 times 99. Okay, get to work. Okay, 2 plus 5 times 99. 497. Piece of cake. So this is our last term. Okay, that's this one right here. It's our last term in the sequence, okay, or in the series. So now the sum of the first 100 terms is equal to first plus last. So 2 plus 497 times, let me write that a little bit better. There we go. Times the number of terms, 100. All right, divided by 2. Okay. So what do we have? Let's figure it out. So here we go. So I have 497, so we just add 2 more. All right, I got to multiply it by 100 and divide it by 2. Okay, or you can just simply multiply by 50 because 100 divided by 2 is 50. So you get 24,950. And that's the total sum of the first 100 terms. All right, so we're getting some experience here, I hope. Hopefully you're figuring this out. So if you'd like, you can pause the video at this point if you want and try the next one. All right, pause and play a little bit. Get active. Try it first and then play the video and see if you got it right. Okay, so if you're big and bold and you want to try it on your own, go for it. Pause the video. Okay, I'm going to assume that you tried it. Okay, so let's detail this out. So the seed or the first term is 3. Out of 50 terms, all right, you got to find the 49th. Okay, piece of 49. So what you do first is you write down your explicit formula first. It's 3 plus the common difference in this case is 6. 3 plus 6 is usually 9. And then plus 6 here is 15 and so on. So the common difference is 6. So 3 plus 6n is your arithmetic sequence. And then you got to find piece of 99. Oh, excuse me, 49. That's a 49. So piece of 49, got to substitute that baby in there, equals 3 plus 6 times 49. Okay, so what is that? So let's try it out. So 3 plus 6 times 49, it's 297. Okay, so 297. This is your piece of 49, which represents your 50th term. Okay, this is the 50th term in the arithmetic sequence. Okay, so once you have that, then you go for it. So the sum of the first 50 terms is first plus last. So 3 plus 297 times 50 terms divided by 2. Okay, so let's figure that out, as we always do. So you add 3 more, all right, times by 50, divided by 2. You'll see on the calculator 7,500. Piece of cake. That's the sum of the first 50 terms. Okay, that's what this represents. Okay. All right, now, what else do we have? Okay, so let's see what other situations we have. Ooh, look at this one. Okay, now these are different. Okay, now, what happens if you don't know how many terms are being added? I'm talking about n, okay, how many terms? That's n equals. How many terms are there? And so the question is, how do you figure that out? Okay, so this one's a little tricky, so pay attention. Okay, we know the seed is 4, okay? This first term is 4. That's your seed or the first term. Your last term, well, that's known. So the question is p sub what? Okay, it's p sub n in general. But what does n equal? Okay, is that p sub 30? Is that p sub 50? I don't know. How many terms are there in this series? That's the big question. Okay, you need to know the common difference. So from 4 to 13 is plus 9. 13 to 22 is plus 9. So there's your common difference. So we know the seed. We know the common difference. We know our explicit formula too, by the way. So p sub n, if we want to use it, is p sub 0 plus d times n in general. So our explicit formula here is 4 plus 9n, and which is kind of nice to know. That's your arithmetic sequence formula there. But the question is, what's n? I need to know this right here. I need to know that. And guess what? I know that p sub n is 922, so I can figure that out. So I'm going to substitute that in. I know the nth population is 922. That's equal to 4 plus 9n. If you solve for it, you get 918 is equal to 9n. And if you divide, n is equal to 918 divided by 9. Okay, so what is that? Well, 918 divided by 9. Look at that, it's 102. So n is equal to 102. And you got to be careful here. This is where you got to be careful. That's n. That's not the total number of terms. Okay, this is just n. So this term right here, your last term, represents, it's actually p sub 102. Okay, it's the 102 population, or the 102nd, 102nd population in the arithmetic series. But how many terms are there? So you got to think about this. We start counting at 0. So how many terms are there from 0 to 102? How many terms? Okay, that's n. Okay, so if you start counting at 1, there's 102 terms. So if you include 0, well, guess what? There's 103 terms, right? There's 103 terms. 103. Whoops, not 13, but 103 terms. Because you start counting at 0, and that, my friends, is n. Okay? Now, well, that's how many terms there are. So I'm not going to call it n. I don't want to confuse anybody. I just want you to understand that you solve for the subscript. When you solve for n here, you get the subscript here. But that doesn't say how many terms there are. That tells you the nth population. Okay, you're working with 102 or 102nd population. But since you start counting at 0, there's actually 103 terms in all. So really what we have to do, guys, is we have to find S sub 103. Now, so you got to think about it. Okay, the most common mistake people make is they think there's 102 terms because they solve for n. But you got to remember, you start counting at 0. So you take first plus last, 4 plus the last term, which is 922, times how many terms you have, which is 103 this time, divided by 2. And that's why this problem is probably the trickiest, because everybody uses 102, well, the people that make a mistake, that is, versus 103. So you got to think about things before you just, start typing things in, okay? You got to be smart about it. So 4 plus 922, hit equals, since I didn't use parentheses, times 103, divided by 2. Okay, you get 47,689. Okay, and that's the sum of the first 103 terms. That, my friends, is what you're looking for. And that's what all these problems here are about. Okay, so what you need to do now is get some experience. I showed you how to do it on the main example, and now you get to apply this, okay, down here. Okay, so if you want, at this point, you can start pausing and playing a little bit and get active into it, okay? So pause the video right now and try the next one. And when you're ready, go ahead and press play. Okay, let's get back to business. I assume you did it. So here we go. The seed is, the first term is 17. From 17 to 23 is plus 6. 23 to 29 is plus 6. There's your common difference. So right away, I can write the explicit formula. So we always start off with this. Write this down every time. Helps you memorize the explicit formula for arithmetic sequences. And so we have 17 plus 6n. What we need to do is find n. Okay, so I know p sub n is 1511, all right? 1511. So what we do is we substitute that in right here, and we solve for n, which is not the number of terms, okay? We always have to add one more because we start counting at 0. So we subtract 17, and we use a calculator a lot. I mean, the numbers get bigger, so let's just clear it and let's start using it. Okay, subtract 17. Work with me now. Just don't sit there and take notes, work with me on the calculator. You get 1494, and that equals 6n, so you got to divide it by 6 to calculate n. Here we go. So divide that baby by 6, and you get 249. Okay, now n is 249, but that doesn't tell us how many terms there are. We start counting. This right here is p sub 249. Okay, so I just found I know the 249th population is 1511, but since we start from counting at 0, there's 0 to 249. Hang on. Wow, okay, everybody, that we got a little crazy right there, okay, but we can go with the flow, so here we go. So the 249th population is 1511, but since we start counting at 0, there's actually 250 terms. 250 terms, so let's write that down. So it's 250 terms in all since we started counting at 0. So that's what I'm going to use in my summation formula. So I got to find S sub 250. So here we go. Let's write that down. So we take first plus last, which is 17 plus 249. Excuse me, not 249. Come on, Ainsworth. 1511. Times how many terms there are. 250 divided by 2. So we got, let's clear this out. So we got 17 plus 1511. I didn't use parentheses, so I have to hit the equal button here. All right, multiply it by 250 and divide it by 2. Okay, I didn't enter it in correctly here, so got to be careful here. Times 250 divided by 2. And you get 191,000. Okay, and there is the sum of the first 250 terms in this arithmetic sequence. All right, now it takes a while to get good, so go ahead and press pause and try the next one here. Okay? All right, on this one, here we go. This is a decreasing sequence here. So from D is equal to 7,999 minus 8,012. So what's the common difference here is going to be negative. So what you have to do is subtract. Always second term minus the first term. You guys already know that. All right, so 7,999 minus 8,012. All right, you get negative 13. Oh my goodness. Okay. And you know the p sub 0, or your first term is 8,012. So my arithmetic sequence looks like 8,012 plus, no, minus, excuse me. Okay, minus 12 times n. So Wait a minute, why did I write down 12? Come on, I'm making mistakes now. Minus 13. Okay, so let me fix that. I'm a little flustered right in the moment. So let me get my focus hat on. So, okay, so I fixed my mistake. What I want to do is find n here, right? So I got to, this term right here, this is equal to piece of n. So piece of what, right? So here we go. So 6,075 is equal to 8,012 minus 13n. Let's subtract 8,012. We're going to get a negative number here, but don't panic because n has to be positive. So we get 6,075 minus 8,012. That's negative 1,937 is equal to negative 13n. So we got to divide both sides by negative 13, and we better come up with a positive whole number. Okay? So n is equal to something here. So divide it by negative 13, and we get 149. So this 6,075, that's your 149th population. All right, but since you start counting at 0, so from 0 to 149, there's 150 terms in all. Okay, that's the special number you're going to be using in your sum. So S of 150 is equal to first plus last, which is 8,012 plus the last one, 6,775. Excuse me, 6,075 times 150, all right, divided by 2. And you do the whole thing on your calculator here. So let's enter it in. So 8,012 plus 6,075, hit equals, multiply it by 150 and divide it by 2. And it is a big number. It's 1,056,525. So 1,056,525. Okay, we're rocking, we're rolling, and let's get some more experience here. So once again, go ahead and pause the video and try another one. Okay, I'm assuming you did it. So the first term, piece of 0, is 6. The last term, your piece of n, is 363. From 6 to 27 is a plus 21. Plus 21. There's your common difference. So here we go. Piece of n is equal to 6 plus 21n. So 363 is equal to 6 plus 21n. So you got to subtract 6 and divide by 21. So minus 6, you get 357 is equal to 21n. And then if you divide by 21, 357 divided by 21 give you 17. So n is 17. So there's 18 terms, okay? This is piece of 17, so there's 18 terms. And that's the special number you're going to be using in your sum formula. So S of 18 is equal to the first plus last, 6 plus 363, times 18 now. Not 17, but 18 divided by 2. So here we go. So 6 plus 363, hit equals, times by 18, divided by 2. And you get 3,321. And that's how it is each time, okay? So after you solve for n, you got to add one more because you got to start counting from 0. You got to remember that. The biggest mistake people make is once they solve for n, they use that number. And they're going to be one off every time. Not one off in their sum, but one off in their calculations in terms of n, which would affect the answer big time. Okay, so pause the video, try another one. So next one, piece of 0, first term, is 5. 5 plus 3 is 8. 8 plus 3 is 11, and so on. So the common difference is 3. So piece of n equals 5 plus 3n. So 56 is equal to 5 plus 3n. That means 51 equals 3n. So that means that n is 17. That means I have 18 terms in this sequence. From 0 to 17 is 18 terms. Notice I'm picking up the speed here because by now we should be getting it. Okay, because it's a little bit redundant. Okay, so here we go. First plus last. 5 plus 56 times 18 divided by 2. All right, let's figure it out. 5 plus 56, not divided by, but times 18 divided by 2. And what do we get? We get 549. Okay, just one more to go. Okay, all right, so pause the video, one last one. All right, let's try this one. So the first term is 75, last term is 475. So let me see, you got to add 25 here. So the common difference is 25. So p sub n is equal to seed plus 25n. Substitute in 475, and that's equal to 75 plus 25n. Subtract 75. You can do this one in your head. 400. And you got to divide 400 by 25, and that should be, what was that, 16? So n equals 16. So there's 17 terms. There we go. All right, so 17 terms. There's your magic number. So S sub 17 is equal to first plus last times 17 divided by 2. All right, we're almost done. So 75 plus 475 times 17 divided by 2 is 4,675. Okay, now that is the basics, okay? Those are the basics. Now let's handle 2 word problems and then we'll be finished, okay? Because you got to be able to apply it to a real problem. So here's one. Okay, an auditorium has 20 rows of seats. The first row has 20 seats, the second row has 21, the third row has 22, and so on. What is the seating capacity? Ooh, that's a total number. Okay, total number of seats. That's called seating capacity. That's what tells you this is a summation problem versus just a sequence problem. Okay, what is the total number of seats? Okay, total seats. So let's outline this. Okay, so here we go. You start off in the first row. This is your first row. At p sub 0, that's your seed. P sub 0 here, the first row is 20. All right, the second one is 21, so you add 1. So p sub 1 is 21. Then you add 1. Notice there's a common difference right there, right? Is 22, of course. So you get the common difference here. So we know the seed and we know the common difference. Those are 2 things you need to know in this problem. The question is, what's the sum of all the seats in the 20 rows? Oh, I labeled this wrong back here. Oh, I'm sorry. Okay, this is what happens, after too many math problems. You need a break, okay? And I haven't taken a break yet. Okay, so let me finish strong here. It's 20 total rows, okay? 20 total rows. Okay, so this is the first row, the second row, third row, okay? And you want the 20th row. Okay, this question is, what is that? Piece of what? Is that piece of 20 or piece of something else? And you got to remember that you don't start counting at 1 here, guys. You start counting at 0. All right, so this is not piece of 20 because if that was the case, there'd be 21 terms. Okay, and there's not 21 terms. There's 20 rows or 20 terms. Okay, so we need to find piece of 19. What would that be? So what we do is we write the sequence formula again, like we always do. So that's p sub 0 plus d times n. And so p sub n is equal to your first term, which is 20. Okay, it says first row right here. This is p sub 0. I'm sorry. Fix that in your notes, guys. First row has 20 seats. That's the seed. Okay, first. And then plus 1 times n, or just plus n. So p sub 19 would be equal to 20 plus 1 times 19, or 19, or what's A? That's 39. So there's 39 seats, all right, in the 20th row. Now make sure you understand that, okay? There's 39 seats in the 20th row, which is the 19th population in this sequence, okay? So I need to find S sub 20. I know there's 20 rows total. 20 rows. So that's first plus last. So the first one is 20 seats. The last one is 39. I multiply by how many terms there are in the sequence, which is 20, and then divide that by 2. So let's figure that out. As we always do. So 20 plus 39 equals, or excuse me, and then you got to multiply that by 20. So times 20. All right, divide that by 2. And you get 590. But 590 what? 590 seats. All right, seats. Total seats. There we go. 590 seats in the auditorium. Okay, so we are learning, hopefully, and hopefully we're getting good. Just one more little problem to go, and then I'm done, okay? And then I'm finished, I mean. So, on the second one here, what do we have? We have a small business that sells $10,000 worth of products during the first year of business. All right, during the first year. So $10,000 in the first year. What does that sound like, guys? I didn't hear you guys. What does that sound like? All right, that's called the seed, guys. Okay, that's P sub 0 or the seed. All right, keyword is first year. The owner has set an annual goal to increase sales. Ooh, increase. That means goes up, right? $75 for the next 19 years. Assuming this goal is met, find the total sales. All right, total sales. That's a sum. All right, during the first 20 years of business. Okay, so we want to increase sales to $7,500. That number right here, okay, if you're going to increase it $7,500 each year, $7,500 is equal to the common difference. All right, it's called D. Okay, so D is 7,500. You're going to add that each year, starting at $10,000. So you start off with P sub 0 is $10,000. Next year, P sub 1, after 1 year, excuse me, after 1 year, all right, you add 75 to that, 7,500. You have 17,500, all right, in sales. All right, so you can see now that this is the common difference. And this represents your first, okay, that's what you start off with. It's the seed. Okay, and then after the 20th year, you got to keep on going. So in the 20th year, okay, this is your first year, this is your second year, and so on, and then the third, P sub 2. Notice that we're one off right there. All right, in the 20th year, what would that be? Would it be P sub 20? Or would it be P sub 19? Tell the person next to you, since you're starting counting at 0, what would that be in the 20th year? All right, and hopefully you've learned something so far that this is going to be P sub 19. What would that be? Okay, since you start counting at 0, you're going to go from P sub 0 to P sub 19 and add them up. And there's going to be 20 terms total. Why? Because you're going to be doing this for 20 years, for the first 20 years. Okay, that's the number of terms. Number of terms. Okay, so no. Where am I at here? So I got to find P sub 19. So here we go. So we got to find P sub n is equal to P sub 0 plus D times n. That's equal to 10,000. Let's do it right here. I'm sorry, it's the end of the night. All right, so come on, Ainsworth. 10,000 here. Got to write it correctly. All right, plus 7,500 n. There's your explicit formula, okay, based upon the seed and how much you're adding every year. All right, now I need to find P sub 19, so I got to take 10,000 plus 75,000 times 19. All right, no big deal on the TID4, you can handle it. So 10,000, just make sure you put the right number of zeros in, okay? Plus 7,500 times 19. Should be a good size number. So 152,500. Okay, that's P sub 19, or the amount in the 20th year of business. Okay, in the 20th year of biz. So we're going to need that. That's your last term. This is your first term. That's your first term. So now what we do is we find the total sales. Again, we're trying to find the total sales. So what do we have? So total sales, which represents in this case S sub 20, all right, is the first plus last. So 10,000 plus 152,500 times 20, because you're doing this for the first 20 years. The first year plus 19 equals total of 20 years, by the way. All right, divide by 2 because you're double counting. All right, what is that? So let's see here. 10,000. Oops, getting a little crazy. 10,000 should be 400 plus 152,000, so plus 152,500. Make sure I enter that incorrectly there. Hit the equal button. Times 20 divided by 2 is 1,625,000. 1,625,000 total sales. Okay? So the big number here for us is this one right here. All right, now the only thing you guys have to do is finish your homework. And guess what? You started it already you already did the previous problems, 10, 11, and 12. And now you got to finish the rest. Okay, so finish all the way up to 16. Make sure you show your work and show all your steps. Make yourself proud, and I'll send the answers out later. All right, do them first, and then check them with my solutions. And I will see you in my next lesson here. And who knows what it's going to be about. But, see you in my next lesson. And remember, this is a video, so if you guys need to see any part of this, okay, you got to remember, you can always rewind and listen to it again, okay? Because it's kind of hard to remember everything I say. So that's why the video technology is so cool these days, because guess what? You have a lesson that's recorded by me where I solve every single problem in your notes, and you can access that anytime, anywhere on the planet, okay? Because it's on my website. So take advantage of it, and I'll see you in my next lesson. This is Mr. Ainsworth. I'm out of here. Bye-bye.